All right, 3.1, linear functions and their properties. So this is a 2-day lesson, so this video is only going to cover examples 1, 2, and 3. And then the next video will cover 4, 5, and 6. So linear function, this is going to go relatively quick. You have done so much work with linear functions in Math 1, 2, and 3, and then so far in this course. So I just really briefly want to talk about a few things. I have an increasing slope, so constant rate of change, same thing. Constant rate of change, so let me make a note of this down here at the bottom. Okay, never mind, there's no room, off to the side. Slope equals the rate of change. Those are the same things, but rate of change, it's more appropriate because not every graph is going to be a line. There might be parabolas, or there might be logarithmic functions or square root functions, and we just want to find their average rate of change. So rate of change is what we're going to start calling it. It's increasing if my slope is positive, which means the graph goes up. It's decreasing if my slope or my rate of change is negative and the graph goes down. It's constant if my rate of change is 0. Which means the graph is just flat. It's a horizontal line. We will use y equals mx plus b for everything. Don't forget your m is your rate of change or your slope, and your b is your y-intercept. Another graph I want to draw your attention to is when we have an undefined slope. It's undefined when your graph is vertical. It just goes up and down. That is undefined. All right, so now let's move on. Example 1, find the slope and the y-intercept. Well, if I'm looking at y equals 2x plus 3, here's my slope, so m equals 2. Here's my y-intercept, so my b equals 3, or you can call it 0, 3. Now to graph this, let me make a coordinate plane really quick. Stupid thing. Try this again. There we go. So I'm going to start at positive 3. Since my slope is 2 up 2 over 1, my rate of change, and I can go backwards down to back 1. There's my graph. So I graphed it. The rate of change. So here's your answers for 1. Here's your answers for 2. Now 3, it says find the rate of change. My rate of change is also 2. It's the same as the slope. And then the answer to part 4, is it increasing, decreasing, or constant? Well, my rate of change is positive. My graph is increasing. It's going up in the positive direction. So my graph is increasing. All right, that's example 1. And you have a bunch of questions on your first quiz involving this example. And it may just be really quick. What's the slope? What's the y-intercept? Is it increasing or decreasing? Graph it. What's the rate of change? So each one of those might be a question on a quiz. Be ready for it. All right, number 2, or example 2. Determining if something is linear or nonlinear. If it's linear, we have to find the slope. For something to be linear, so let me go off to the side and give you a definition. Linear has a constant or a common, this is how you guys are used to it, difference. So in Math 1, you start learning this terminology, a common difference. It's adding the same amount every time. So it's going to add or subtract same amount. So I'm going to look at my tables, and if you guys need to write that, pause it and write it down. I'm going to look at my tables. And when I look at A, my x is increasing by 1 all the way through. And make sure you check all the way through. Don't just check the first couple of values. Check through the whole table, please. So from negative 26 to negative 24, I'm adding 22. Then to go from negative 4 to 2, I'm adding 6. As soon as you see they're not the same, it is non-linear. Then I go to B. Again, my x is increasing by 1 every time, so that's good. Then I go to my y, and to go from -4 to -3.5, I am increasing by a half. And it just so happens that all the way through, I am increasing by a half. So if I'm looking at this and I don't automatically see what it is increasing by, you take the second term, so -3.5, and you subtract -4. Use your calculator. But anyways, that's going to give you 0.5. And you can do that all the way through. 3 minus -3.5. -2 minus -2.5. So all the way through, you can do this for every single one, and each time it's going to give you 0.5 if you're stuck on that. Because it's the same all the way through, it is linear. To identify the slope, well, this is your slope. Whatever it's increasing by, that's your slope. Don't overthink this, you guys. This is really simple. All right, the last one for this video. Example 3. Suppose that you are given f of x and g of x. These are both linear. They're just in y equals mx plus b. I have my work here. I didn't feel like erasing it and doing it over again because it shouldn't be too bad. When I see solve f of x equals 0, well, f of x, here's f of x. So I take the 3x plus 5 and I set it equal to 0. Then I go through and I solve for x. I'm not going over how to do that. You should know that. Then for b, it says f of x is less than 0. So it's the same thing that I did in A, but with a less than. And then I go through and I do the exact same work. So I subtract my 5. I have 3x is less than -5, divide by 3. And x is less than -5/3. So you can see you get the same answer for both. One's an equation, one's an inequality. Now, a quick note that you should write on a Post-it note. Pause this, write this down after I'm done talking. Every single time you divide with an inequality or multiply, be careful. If you multiply or divide by a negative, you must flip the inequality around. So if I have a -2x is greater than 4 and I divide by -2, I have to flip my inequality. Please make sure you remember that. It is super duper important. Okay, pause it, write it down. All right, now let's finish going over this example. In C, it says solve f of x equals g of x. So I'm going to take my f of x, I'll redo this one. I'm going to take my f of x, which is 3x plus 5, set it equal to my g of x, which is -2x plus 15, and then I'm going to solve for x. So I'm going to start by adding the 2x. So I'm combining like terms. So I have 5x plus 5 equals 15. Then I'm going to subtract the 5. And I have 5x equals 10, so x equals 2. And then in D, it's the same thing, except for you have a greater than symbol. You go through the same process, add the 2, subtract the 5, divide by 5, and you still get 2, but with an inequality. It's just x is greater than or equal to 2. And then the last one, E, says graph f of x and g of x. So I do have these graphed already for you. I am not going to go over how to graph those. I did go by ones, however. Now it says label the point that represents the solution. The solution is the point, let me move these, they're in the way, is the point of intersection. So that's what you're looking for. So in this case, my point of intersection was 2, 11. And the only reason I rewrote these is so I wouldn't have to scroll back up for when I was graphing. All right, that takes care of examples 1 through 3. If you have any questions, write them down, and I will go over them in class tomorrow.